In the previous video, we talked about different properties of parallelograms. So if you knew it was a parallelogram, there were certain properties that you could assume based on that. In this video, we're going to do pretty much the basic opposite of that, and I'm going to give you some different properties, and you have to determine if that quadrilateral is a parallelogram or if there's enough information to say that there is a parallelogram. So there's four first reasons, and that would be if both pairs of opposite sides of a quadrilateral are congruent to each other, then that quadrilateral is a parallelogram. So if you look at our picture over here on the far right, you can see that we have two pairs, so two of the opposite pairs of sides are congruent to each other, then we know that this is a parallelogram. Our next reason, we're looking at our picture right here, we can see that the opposite pairs of angles are congruent to each other. So if both pairs of opposite angles in a quadrilateral are congruent to each other, then we know it is a parallelogram. The third reason is if we have one pair of opposite sides in a quadrilateral needs to be congruent, and it also needs to be parallel to each other. And if you look at your picture right here, they need to be both parallel and congruent to each other. The fourth reason is we need to have the diagonals of the quadrilateral need to bisect each other. When we look at our picture, you can see that these two pieces of your diagonal are cut in half, and then the diagonal BD is also cut in half. So notice that all four of them are not the same with each other, but just one diagonal is cut in half and the other diagonal is cut in half. One other extra reminder is that when we are finding the length of a segment, this means that you might need to use either Pythagorean theorem, so a squared plus b squared equals c squared, by drawing a right triangle on your graph, or you could always use the distance formula. We are going to use these four different reasons to determine if these four pictures, 1, 2, 3, 4, are parallelograms. On number 1, we can see that we have an opposite set of sides that are congruent, and we have a different set of opposite sides that are parallel. And if we remember up above, we need to have one set that is parallel and congruent. This would not be a parallelogram. In number 2, this one's a little bit tricky, but if you remember back to our congruent triangles, we see two triangles formed here. This middle piece will be congruent to each other, and now the two triangles all together are going to be congruent to each other by side, angle, side. So if the whole triangle is congruent, we already saw these original markings on there, but that means that this third side is also congruent to this third side. And now if you notice, we have a pair of opposite sides, and we have another pair of opposite sides that are congruent. So this is a parallelogram. The reason why is because we have two pairs of opposite sides that are congruent. I want you to now answer number 3 on your own, yes or no, and your reason why. You should have answered no, it is not a parallelogram, because you have one pair of sides that are congruent to each other, and you have one diagonal that is cut in half. You need both diagonals to be cut in half, or you need both sets of sides to be congruent, and you only have half and half of each of those. Number 4, we have some different angle measures, and if you notice, the side-by-side angles are supplementary to each other, so they equal 180 degrees. That tells you that these two sides are going to be parallel to each other. If we look at the other two pairs of angles, we have 107 plus 73 again, and those also equal 180 degrees, which means they're supplementary. That tells you that these other two sides, making little triangles there, are going to be parallel to each other as well. So we have two sets of opposite sides that are parallel to each other. So yes, this is a parallelogram based on the definition of a parallelogram. With question number 5, we need to use the values that are given, so x equals 6 and y equals 3.5, to put into the x and y values in our picture to determine if we have enough information then to say that that this quadrilateral is a parallelogram. And if we do that for the first pieces, I'm going to do the x's in purple. And if we have x is equal to 6, that gives us 4 times 6 minus 10. So that is 24 minus 10. So 14 is that piece. We do the same thing up here for 2x plus 2. So 2 times 6 plus 2 gives us 12 plus 2. So also 14. So that tells you that these two pieces of our diagonal are congruent to each other. So it is bisected. We also have to check to see if the other one will be the same. I'm going to do the other diagonal, or my y values, in orange. So right here we're going to do 6 times 3.5 plus 1. 6 times 3.5 is 21, plus 1 more is 22. If I do this other one, I'm going to scoot it down here, down to below. So I've got 8 times 3.5 minus 6. 8 times 3.5 is 28. Minus 6 gives me a 22. So that tells me these other diagonals are also bisected. Because we know that both diagonals are bisected, this implies that JKLM is a parallelogram. 6 is going to be the same idea, so we need to put in the values of A and B into our picture and determine if that's enough information to say that this is a parallelogram. And if we go ahead and do that for the A, so A is 2.7, so 7 times 2.4, sorry, 2.4, not 2.7. And 7 times 2.4 is 16.8. So that's what this one side will equal. Let's do the same thing over here for the 2 times A. So 2 times 2.4 plus 12. 2 times 2.4 is 4.8. Plus 12 more gives us a 16.8. So you have one set of sides that are opposite of each other that are congruent. And next, I want you to put in the values of B and tell me what is the value of Q going to be. Angle Q then, if we take 10 times the B minus 16, that gives us 90 minus 16. So that would be a 74 degrees. And now if we do the same thing for angle R, so angle R is 9 times the B, which is 9, plus 25, so that's 81 plus 25. And 81 plus 25 is a 106. Notice these are not congruent to each other, but they are supplementary to each other. And the big thing you want to notice is in our picture, if we have these two pieces are congruent and our two angles are supplementary to each other, that means that there are two sides that are parallel to each other, and that would be these same ones that are congruent. And since we have one pair that is congruent and parallel, then yes, this is a parallelogram. Number 4, I would like you to first find the values with the x value put in there. So what is the length of JK and what is the length of ML? So we need to find both of those right now. JK and ML should both be a 27. This gives us one set of opposite sides that are congruent to each other. And now I want you to find what the values with y are going to be. So that would be JM and LK. So now go find what those values are as well. Once you put those in, you should realize that we've got 9 plus 4, and we also have 2 times 9 minus 5. So both of these come out as 13. So we have another set of opposite sides that are congruent to each other. Since we have two pairs of opposite sides that are congruent, this implies that yes, that JKLM is a parallelogram. Before you go any further, go ahead and graph number 8 and then come back and work this out with me. You need to find the slopes of all 4 sides, and using that information we are going to determine if this shape, or our quadrilateral, is a parallelogram. So if we are dealing with these slopes, we want our opposite sides need to be parallel to each other, and that's what we're kind of checking for. On the first one, so the slope of AB, if I count on my picture, I have a rise of 4 and a run of 3. So this would be a 4 over 3. Now also it's going downhill, so it's negative, so a negative 4/3. Next, for the slope of B to C, I can go across and down, and across is 8 spaces and down is 1. So my rise is 1, run is 8, and again it's negative. And I want you now to find the slope of CD. The slope of CD, if we go across and down, it should be a 3 and a 4. So the rise is a 4, run is the 3, and it is negative still, so those are the same. Because those slopes are the same, that means that we are going to have parallel sides for those 2 slopes. All right, so for the slope of BC, or not BC, sorry, DA or AD, so across is 8, up is 1, so my rise is 1, my run is 8, and that is also a negative. And we can see that these also will have the exact same slope, which means that they are parallel sides. Since both pairs of opposite sides are parallel to each other, that means that we are going to have a parallelogram. And number 9, go ahead and graph it. Now that it's graphed, you need to compare the lengths of all 4 sides. So the distance formula, or you could use Pythagorean theorem on all 4 sides. And since we've got a graph, I'm going to use Pythagorean theorem because it'll be a little bit easier to count, just like we did for the slope. For the side M to N, I'm going to make my little right triangle. And you can see that across and down, so this is my M, that's my N. And up and down I had 2. Across I have 2, so this would be 2 squared plus 2 squared equals x squared, because my x is my hypotenuse. So I get 4 plus 4 equals x squared, so 8 equals x squared. My x then is the square root of 8. If you remember back on how we need to reduce that, so if I pull out a 2 and a 4, I can divide that down to a 2 and a 2. So I get a 2 on the outside, and then my 2 is left inside. So this would be my length of MN. We're going to do the same thing now for NO. So N to O, draw your little triangle. So it's a little bit taller up and down. And across there's only 1 little space, but up and down there are 4. So I would have 1 squared plus 4 squared equals x squared. And now I want you to tell me, what is your x value going to be? Once you simplify, you'll get a 1 plus a 16. So you get a 17 equals x squared, and then you take the square root of that. With 17, there's no perfect squares we can pull out, so that's all that your NO side is going to equal. On the PO side now, we have our O is down below, P is up above, and again we have 2 and 2. And if you notice, our triangle is going to look identical to this first one, so if you want, you could just skip all of your steps. Once we know it's 2 squared plus 2 squared equals x squared, and we know we'll get the square root of 8, so then PO will be exactly the same. And these are opposite sides, so your opposite sides in your picture are going to be congruent to each other. So far so good in our picture. If we find out that the MP side is congruent to NO, then we'll have 2 sets of sides that are congruent to each other. So MP, if we draw our triangle there, we have an M up here, our P is down below, and we have 1 across the top and 4 on the side. We have an identical triangle, which means that side MP is also going to be the square root of 17. Again, those are opposite sides. And they will be congruent to each other. So we have two pairs of opposite sides that are going to be congruent. This tells us that MNOP is a parallelogram.